So I give you a bunch of functions. F of x equals 4 sine x, g of x equals cos 4x, and h of x equals tangent inverse of x. And I want you to calculate g of pi over 2 minus g of pi over 4 divided by pi over 2 minus pi over 4. So how do we do this? What's g of pi over 2 mean? Yeah, plug in pi over 2 to your g function, which is up here. G of x equals cos 4x. All right, so you're given that. G of x cos 4x. So then you start by plugging pi over 2 in for x. So this will be cos of 4 times pi over 2 minus cos of 4 times pi over 4, all divided by pi over 2 minus pi over 4. Now, for some reason that I have yet to be able to explain, students like to do cos of pi over 2 and then bring the 4 out and just multiply by that later. So the whole reason I give you this problem is so that you know the difference between 4 on the outside and 4 on the inside. The 4 on the inside means you have to do that multiplication before you get to the cosine. So the first thing you're going to do after plugging in pi over 2 is to multiply 4 times pi over 2, which should give you what? 4 pi over 2, which is 2 pi. Right, so this guy becomes 2 pi. This guy becomes pi. On the bottom, let me deal with that in a second. Let me ignore that for a second. It's stressing me out, so I'm just going to ignore it. I know cos of 2 pi. What's cos of 2 pi? 1. Yes, I agree. Does anybody not agree? You agree too? That's like 3 of us? Good. Majority. Exactly. Cosine of pi is -1, so this will be minus -1 over pi over 2 minus pi over 4. So 2 on top. All right, I got to deal with the bottom. So I get a common denominator, which is 4. Oh, but I don't have to multiply by 4. I have to multiply by 2. All right, that'll give me my common denominator of 4. So this becomes 2 pi over 4 minus pi over 4. 2 pi over 4 minus pi over 4 is again 1 pi over 4. But then this guy has to flip up. So when you flip and multiply, you end up with 8 over pi.
Yes, please.
Are you sure just because I put a b here that doesn't make it 4b? All right.
In math, it could be.
All right. Thank you. So let's do this then. Same idea, but has an x in it, so that makes it a little harder, right? X has to be less than 0. All right. All right. So then it's the same idea though. What does cos inverse represent? An angle or a ratio?
It takes in a ratio.
It takes in a ratio and spits out an angle. So this whole thing you want to think of as an angle. Specifically, it's the angle that makes cosine equal to 2/5 x. So what the question is asking is for you to find sine of theta given cos theta equals 2/5 x, with this restriction that x is negative. All right, so I have to draw a triangle using this fact that cosine theta is 2/5 x, and the quadrant that I draw the triangle in helps me get the right sign at the end of the day. So what quadrant should this be in and why? So there's 2 things to look at when you're determining quadrant here. The first is the fact that this is cosine inverse. Cosine inverse only comes in 2 quadrants, right? Where does cosine inverse put you?
1 or 2.
1 or 2, right? So cosine inverse is between 1 and 2. And then the second fact is that cosine of theta is equal to a positive or negative? Negative, right? Because x is less than 0. So altogether, this whole quantity, because x is less than 0, this whole quantity is negative. Which means that I'm going to be in quadrant 2 or 3, and then because I already have these two quadrants isolated, right, I already said I have to be in 1 and 2, cosine being negative puts me in 2 or 3, which means my overlap is 2. Okay, I gotta be in quadrant 2. So I draw my triangle in quadrant 2, my angle theta. Now, I have to label the triangle. What am I going to look at to label this triangle? The 2 fifths x. More specifically, I would think of that as a fraction. If you multiply this out, you can rewrite it as 2x over 5. So you see that your adjacent has to be 2x, because this is cosine. So adjacent is 2x, hypotenuse is 5. Right? Cosine is adjacent over hypotenuse. So I'll label this guy here 2x, this guy here 5. Oop, nope. This guy here 5. Then I do my Pythagorean theorem to solve for this side. I'll call y. So I have to do 5 squared equals y squared plus 2x squared. Y squared is equal to 25 minus 4x squared. Y is equal to the square root of 25 minus 4x squared.
Josh, for the 2x, would it not be negative? Or
So an extra negative sign on the x right now would actually turn it around and make it all positive, right? Because x is a negative number, so imagine in your head x equals negative 1/3. Like the negative is, because x is less than 0, the negative is encoded inside of this x. If you put another negative in front of the x, you'd be turning it into a positive. So this is negative as written. Y is positive because it's going up. It's 25 minus 4x squared. So how does that give me my answer? What am I looking for ultimately? Sine, right? So I focus on this triangle and I pick off sine of theta, opposite over hypotenuse. Root 25 minus 4x squared over so sine of theta, or sine of cos inverse of 2 fifths x, should be this ratio.
and you don't try to simplify the root at all?
You could try to simplify the root, but you probably fail. How do you want to simplify it?
They're all squares.
They are both squares. And whenever you solve the Pythagorean theorem, it's always going to be squares because you squared them to solve it. But if it's not a multiplication, you can't simplify it. If it's plus or minus, it's never the case that a squared plus b squared square root. This is never equal to a plus b. Right? If you take 36 plus 25 and you square root it, it's not going to be 11. It's not going to be 6 plus 5. You're going to have to actually add these up first and then take the root. So.
Thanks. Can we do one more?
I guess.
6C.
C graphs -4 sine 1/3 x plus 1.
Yep.
-4 sine 1/3 x plus 1. Now, that plus 1, is that, well, what is that? What's that plus 1?
Vertical.
Phase shift or vertical shift?
Vertical.
Vertical shift because it's not in parentheses, so it's not attached to the sign. Right? The only thing that's inside the sine function right now is the 1/3 x. Right? As soon as you add or subtract, that doesn't have as much precedence. That goes outside of the function. So if I wanted the 1 to be in there, I'd have to do this. Okay? But I didn't. So I mean this. So we calculate amplitude, period, phase shift. Amplitude is 4, right? But it's negative, so that's going to reflect, right? Remember that. The period is 2 pi over b, which is equal to 2 pi over 1/3, which is equal to 6 pi. And the phase shift is c over b, but since nothing's being added or subtracted inside the parentheses, this will be 0. And then after we graph this at the end of the day, we also have to move on. So the quantity that helps me calculate my x values, all the important x values, is actually the period over 4. So let me go ahead and get my quarter periods while I'm at it. Period divided by 4 should equal 6 pi over 4. So 3 pi over 2 when you reduce. Since I'm starting at 0, my first important x value will be 0. And my next one will come 3 pi over 2 units later. I'll start from 0, then I have a 3 pi over 2. Then my next important x value comes after another 3 pi over 2. So 6 pi over 2, 9 pi over 2, 12 pi over 2. And you keep adding 3 pi over 2 to get your next important x value. Because the amplitude is 4, I'm going to bounce between 4 and -4. Because I want to graph a sine function, does sine start at a max, a min, or a 0? 0. So because I'm graphing a sine function, I start at 0 on the y-axis. Am I going to go up first or down first? Down because of the reflection. So 0, min, 0, max, 0. Now this is just one period of -4 sine 1/3 x. What's the plus 1 on the end going to do? Move everything. So, depending on how lazy you are, you can draw that on the same axis. I'm actually very lazy, but turns out that if I do that on the same axis, you probably have no idea what I drew. Draw it again. So now instead of bouncing between 4 and -4, I'm going to go all the way up to 5 and down to -3 because everything's getting shifted up one. And I usually draw my new axis, this y equals 1 line. Because I'm shifting up 1, this is the line that everything's going to oscillate around. So instead of starting on the x-axis, I'm going to start up here on y equals 1, right, move up 1. Then I'll go down to a min of -3, back up to y equals 1, up to a max of 5, back down to y equals 1. So this is supposed to be this entire graph shifted up 1. See, it's now oscillating around y equals 1. Yeah, so watch out for the parentheses. There's no parentheses in the problem, when there's no parentheses written, everything connected by multiplication or division is inside of the function. Everything connected by addition or subtraction is outside. So like, if I wrote cos 5/3 x plus 2, these guys connected by multiplication are in, this guy connected by addition is out. If I wanted him in, I would have to move my parentheses and physically put one.